Hey guys, welcome to another video. So today we continue on with the nice question series that we have. So today's question comes from the advanced syllabus, so 2-unit maths, a classic question relating to exponential growth and decay. Now, the question I'm going to do today, it's recycled in so many past papers in so many schools, right? It originally came from the HSC 2013. So let's jump right into it. But actually, before I go on, if you haven't subscribed to the channel, please do so. Tell your friends, like the videos, and yeah, let's get started. So today's question comes from the HSC. You might recall, so I like this question because exponential growth and decay in advanced maths it can be quite predictable, right? You either get exponential growth or radioactive decay. This one here sort of has elements of both, right? In fact, it's got two items sort of moving with exponential growth and decay, and you just got to work out the interactions between the two. So let's dive right into it. So this question starts with, introduces trout and carp. In fact, you know what I'll do? Anything related to trout, I'll highlight in blue, and anything related to carp, I'll highlight in green. So you might have seen this question before. It's a nice one, right? So let's see. A lake contains a number of trout, right? At a certain time, 10 carp are introduced. So 10 carp are introduced into the lake. So that looks like, in fact, maybe I'll annotate it as I go. So when t equals 0, right? Surely t equals 0. Carp is 10 into the lake and start eating the trout. So carp start eating the trout. So I'm assuming carp would increase and trout will decrease. So as a consequence, the number of trout, so this is blue now, is that. It's quite important actually to identify what is relating to trout and what is related to carp, just so you know and you don't confuse yourself. Where t is a month after carp is introduced. Okay, cool. The population of carp, so this is green now, is this, right? They gave you two formula. N is the population of trout, P is the population of carp. Okay, cool. So first question, how many trout were there in the lake, right? When they were introduced, okay, when t equals 0, what's the number? When will the population of trout be 0, right? Sketch number of trout over time, okay? What is the rate of increase? When is the rate of increase of carp equal to the decrease of trout? Okay, so set the differential equation, so dp dt and dn dt to be equal. And last one, when is the number of carp equal to the number of trout? Okay, cool. Sounds simple enough, but I guess some people get confused with the fact that there are two variables, right, happening at the same time. So, part I, pretty easy. So, how many trout were there when the carp was introduced? So, when t equals 0, right, it wants to know what n is, right? Question mark. That's a 1 marker. Pretty straightforward. So, guys, sub 0 into the n formula. So, n equals to 375 minus e to the power of 0.04 times 0. That's obviously 1, so therefore n equals to 375, right? 375 trout at the start. Pretty easy. Nothing hard about that. When will the population of trout be 0? So when n equals 0, right? So 0 equals to 375. Once again, pretty straightforward exponential growth, exponential equation. Throw that over. 0.04t 375. You guys know that natural log both sides, so 0.04t equals to ln 375, and then divide the 0.04 over. So let's see, right? And then punch in your calculator. Now, if you did it right, I believe the answer is like 148.2 something, right? So therefore, 149 months, right? I hope I'm not going too fast for people, but yeah, I don't think this is particularly hard, very textbook, right? That's what I do this question because it's so common, right? It's such a common question that gets recycled, yeah? Now, part 3, sketch the blue graph over time. Okay, that's just an exponential graph. All right, let's see. So I'm sketching n equals to 375 minus, it's a negative exponential graph, 0.04 t, and I believe it's negative, is it? No, it's positive. Okay, cool, that's fine. So we know that, like a positive exponential graph looks like that, with a minus in front, it sort of goes this way and then shifted up by 375, right? So this graph here, right, this is N and this is T. So it's basically like this graph here, but down here, something like that, right? Where this is time 0. And we know that this is 140. This point is 149 months, right? And I know that at the start there were 375 trout, and that is N equals to 375 minus 4T. Nice, right? So this question isn't meant to be hard. It's just very common, and I like it because it's just so I'm just doing just a nice little variation to your usual exponential growth question, right? Because those questions are so typical, exponential growth, decay, right? Very active decay, boring. This one here, bit of spice, right? Okay. When will the rate of carp equal to the rate of decrease of, increase in carp equal to the rate of decrease in trout? So basically set the two D's to be equal, right? So I have already, so I'm just going to zoom in, part 4. I already have dp dt, right? This is carp equal to, so let me see, that was a green, 0.02p, right? And I have n equals to 375 minus e 0.04t, right? I have those two things, right? So I need to set this guy equal, right? So let's see. Now, the best way for you to think about this is, well, maybe I'll start with this side, right? So dn dt equals to, now if I differentiated this, sorry, I've got no horizontal space, so I'm just going to move this over a bit. Perfect. Right. So differentiate that, put the 0.04 down, right? Differentiate it and then multiply it by negative e 0.04t. Now, before you combine it, I want to show you something, right? See this bit here, right? You can make that the subject from upstairs, right? Where if you did, then you sort of get like minus e 0.04t equals to n minus 375, right? Sorry, I'm a bit off page now. Let me bring that back on page. Okay. So this is what I'm going to sub in, right? This thing here into here. Yeah. So actually, do I need to sub that in? Let me think about it. Normally I would if I was to prove it. So actually, let's park that for a second. I might actually just use this expression, right? Because then maybe I could find an expression for, yeah, that's right. I'll keep that. I don't need that top bit, right? Sorry. That was part of, normally I just went on robotic mode when I tried to demonstrate that the differential equation, also the equation, the solution. No. So leave that there, right? Tick. On this side though, right? We know that this is the green formula, right? And this was the blue one, right? So what I'm going to do is try to find an expression for P, right? So I know so then I can set the two P's to be equal. So can I just use this space down here, right? Now I know that this guy here always has this formula, right? K in this case is 0.02 P, right? Are you guys okay with that? For any sort of exponential growth question, it'll look like that. Sorry, not times P, times T on top, right? And this is exponentially growing, right? So it should be a positive power. Now, this one here, actually, let me see, 20, 0. Yep, this makes sense. Okay, so now I already know, actually, let's just skip to it, right? I know that initially, how many carps were there? 10, wasn't it? Yep. Yeah, let's write it. Let's do full working out. When t equals 0, p equals to 10, which basically means 10 equals to a e 0, so a is 10, perfect. Right, so therefore p equals to a e 0, oh sorry, not a now, 10 e 0.02t, perfect. Now, why am I doing this? Because now we know, right? I can now sub, let me get rid of the highlighting just to demonstrate, right? Now I can sub this guy, this P here, this part here, sub that into there. Because then I can get an expression for dp dt in terms of exponential time, and I'll set it equal to the pink circle, right? So sub that in. Let's see what we get, right? So therefore, dp dt equals to 0.02 multiplied by 10e 0.02t. So simplify that. dp dt equals to 10 times that 0.2 e. Okay, perfect. Look at this, guys. So now, if this is the green circle, right, and I've got the red, so the pink circle, and I'm going to set it to equal to each other and then solve now. How much space do I have? Yeah, that's enough, I think. That's enough. So let's say, therefore, if I set dp dt equal to dn dt, right, then 0.2 e 0.02t would equal to, now what was the pink circle? 0.0, negative, okay. Negative 0.04 e 0.04t. Quick check, make sure it's fine. All right. Now, the language is quite important, right? See that negative there? It's going to throw a lot of kids out, right? Because it goes, when is the rate of increase equal to the rate of decrease? The fact that it already assumes that it decreases, I don't need the negative there, right? So let me say that again. The rate of increase, if it said, what's the rate of change, right? If it just said, what's the rate of change of carp? Oh, sorry. When the rate of change of carp is equal to the rate of trout, then yes, you need a negative in there. But it already says, when is the rate of increase, assuming it's positive, equal to the rate of decrease, right? So you don't actually need a negative here. Yeah, because it's already, the rate of decrease is 0.04, right? It's already got the negative in front of there. So I guess what I'm trying to say is don't need the negative there. And now we're just going to solve this. Yeah. So the best way to solve this is, well, let's get a whole number first. Just trying to have a look at. So perfect. So what I'm going to do, so if I take this guy here and I divide it over, and divide by this guy, right? 0.2 divided by, I think it's 5. Yeah. 5e0 2t equals to e0 4t. Now bring the 5. Maybe log both sides, right? Yeah, let me see what's the best way of doing this. Yeah, ln both sides. Is that the best way? Yeah, okay. Yeah, I'm thinking about bringing it over, but yeah, let's not do anything fancy. Let's just ln both sides, right? ln e 0.04t. So I got split that out using the log laws. ln of e 0.02t. And guys, I know that ln of e are mutually inverse, so it becomes 0.4, which is what this is. So ln 5 plus, that's mutually inverse, 0.04t, minus that over. So I got 0.02t equals to ln 5, right? And just punch it in the calculator. So do I have any vertical space? Just need like 2 more lines. Yeah, I do. Just. Okay. So then let's finish it off. T equals to ln 5 divided by 0.02. Right, and if you punch that in the calculator, it's approximately 80.47. Yeah, so therefore, now does it tell me to round it? No, it just says that. So maybe go, I don't know, 80.5 month. Yeah. So that's okay. So the hardest thing about this question is figuring out, once you know, right, that you're going to set dp dn equal to each other, right? The trick is then to basically find an expression for dB dt in terms of the exponential, because then we have the n dt in terms of the exponential, and then set them equal to each other. And then also the negative here goes away because it's the rate of increase equal to the rate of decrease, right? It already assumes increase equals to decrease, so you don't need a direction there. You don't need a negative extra. Solve the exponential and then you have it. Guys, let's finish off with the last question there. So when is the number of carp equal to the number of trout? So that's basically, instead of setting the differentials equal to each other, set the p equal to the n and then solve, right? So for the next one, I'll just start off with a new tab here. So for number 5, I want p equal to n, right? That's really what it's saying now. What was p? P was 10, was it? 10 E02, okay. Okay. So 10 E 0.02t, set that equal to n, which is 375 minus E 0.04t. Okay, cool. Now, these values of K were not sort of random, right? It's actually specifically chosen so you can do this question. I like it. This is why I really like part 5, right? It was well thought out. So, because if you think about it, this is like this guy by half, right? So when I bring it over, right, you sort of get like E 0.04t plus 10 E 0.02t minus 375 equals 0. Now, for those that know, like I said, this guy here, specifically chosen for this, it's almost like a quadratic, right? Because if you think about it, this guy is actually E 0.02t squared, isn't it? Right? It's actually a really nice quadratic. And I'm hoping, I'm not certain, but I'm hoping that 375 can be factorized. I think it can be. Right. So if you use U sub, right, you just replace this guy and this guy with the letter U. Yeah, so let U equal to E 0.02t. Then you would go U squared plus 10U minus 375. It's a nice question, right? Nicely hidden question. How many marks, by the way? 2, 3, 3. This is an 8 marker. Wow, 8 mark exponential growth and decay question. Guys, I think that's nicely factorizable. What do you say? 25 and 25, 15, I believe. That's a plus, that's a minus. So U equals to minus 25, positive 15. Right. Now, we know, right, when you do this, sub the exponential back in. We know that exponentials can't be negative, so you actually can't get rid of that guy. So E 0.02t equals to 15 only. Right, exponentials can't be negative, right? So you can actually say to yourself, right, because E of X has to be greater than 0, right? Yeah. So then, now ln, and then divide by that. So 1 on 0.02, ln 15 on your calculator. All right. What's that give you? I think 135.4. Yeah. So therefore, 135. Now, because it doesn't say, maybe you should go 0.4 months, right? Or something like that. Or 0.5. Yeah, maybe I'll go 0.5. No, leave it. Yep. Guys, thought I'd give you that question. Nice quick burst. Nice exponential growth and decay question. Not your typical population growth or radioactive decay. From the HSC, recycled a few times. I reckon there's a good chance that your teacher, 2013 here, it's been 10 years, right? Maybe they'll recycle it into your trial paper or something similar, right? Guys, hopefully that was okay. Like the video, subscribe to the channel, and tell your friends, and I'll see you at the next video. Thank you.